folks. Welcome to
Vector calculus.
So our most basic parabola, the one we should all know, is this one, right? The happy face looking parabola. And that parabola, Alright, ladies and gentlemen, welcome back to the next lecture in vector calculus. Today we want to take a look at 3 examples of actually plotting ellipses. So let's go ahead and take a look, alright? Our first example is going to be, so here's our first example. I've got it right here with me. So find the equation of the following ellipse, okay? We want to find the equation of the ellipse with the following properties. It has vertices at plus minus 9, 0, and it also has a minor axis whose length is 7. Okay, so using just these 2 pieces of information, we actually have to find the equation of our ellipse. Okay, so how do we do that? Well, the first thing we have to do is actually visualize what's going on, right? Visualize what's going on. So first and foremost, what I'd want to do is ask the question, is this a horizontal or a vertical ellipse? Well, take a look at what coordinate is changing. You see that the x coordinate is changing, right? Plus minus 9. That tells us it's immediately a horizontal ellipse. Okay? Maybe we can draw that better, but the moral of the story is the same. We have a horizontal ellipse. Okay? Now, given that we have a horizontal ellipse, do we know any information about it? And as a matter of fact, we do, ladies and gentlemen. First thing we know are the vertices. The vertices. We know one vertex is at 9, 0. The other vertex is at minus 9, 0. Okay. Now, remember the distance from the center of our ellipse. Let's say this is the center of our ellipse. The distance from that center to either one of the vertices is going to be the variable a. And so if we know the distance from this center to this vertex is 9, we know the value of a is 9. Right? And of course we know what the center is, right? The center is just going to be the origin. Right? If you take the midpoint of minus 9, 0 and 9, 0, it should make sense that the center of our ellipse is 0, 0. Okay? So we've already got 2 vital pieces of information. And what are those 2 vital pieces of information we have? We have the center of our ellipse and we have the a value. Now, we also know the minor axis length. What's the minor axis? Remember, the minor axis is the length of this axis right here, the smaller axis. Remember that smaller axis is going to be 2 times our b value. And so if the whole minor axis is 7, we know 2 times our b value is 7. And so b is 7 over 2. And now we have all the information we need. We have our b value, we have our a value, and we have the center of our ellipse. So let's go ahead and write down the equation. The standard form of any ellipse, remember, is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. And now we can just plug and chug, right? What's the center of our ellipse? The center of our ellipse is 0, 0. And so instead of writing h, what can I write? Well, I can simply write, let's go ahead and write this down, x minus, well, what's the x coordinate of my center? It's going to be 0. So I'm going to write x minus 0. Square that over a squared. What's my a value? 9. So put that in. Okay, let's rest that over there. So I'm going to have my a value, but remember to square that. Plus y minus k. What's my k value? The k value is the y coordinate of my center, which is also 0. So I'm going to go ahead and write down 0 over here for my k value. Square that and divide it by b squared. What's my b? My b is 7 over 2. 7 over 2. And remember, I have to square that. And finally, what am I left with? All of this is going to equal 1. And so that, ladies and gentlemen, is going to be the equation of our ellipse. So isn't that fantastic? using just two pieces of information, we were able to actually derive the equation of our ellipse. Alright, so let's go ahead and do two more examples. So, let's take a look at our second example. Our second example, we're not going to have the same values, and we're definitely not going to have the center of the origin. So hopefully we can mix things up a bit. What's our second example? What do we have for that? So for our second example, we actually have three givens. We have the center, the vertex, and the focus. So we have the center of our ellipse at -5, 4. We have the vertex of our ellipse at 1, 4. And finally, we have the focus, one of the foci of our ellipse, which is 0, 4. 0, 4. Alright, so first thing we want to know is this a horizontal or a vertical ellipse? Well, to answer that question, look at what coordinate is changing. Look at what coordinate is changing, right? And you see, it's gonna be my x coordinate, right? So automatically, I can tell this is gonna be a horizontal ellipse, okay? So let's go ahead and draw a horizontal ellipse here. This time I'll make it pretty big. So that's my horizontal ellipse. Alright, so I know a few things about my horizontal ellipse. Let's go ahead and take this marker. So first of all, I know the center of my ellipse is gonna be -5, 4. That's going to be my center, -5, 4. I also know one of the vertices, right? One of the vertices of my ellipse. Perhaps this vertex at the far right. Okay, that vertex is going to be 1, 4. 1, 4. And finally, I know the focus of my ellipse. Remember, every ellipse has two foci, but here I at least know one of them. And this focus right here is going to be 0, 4. Okay, so I know three pieces of information about my ellipse. I know my center, my vertex, and my focus. Now, given these three pieces of information, I want to find out the equation for my ellipse. Now, what's the general equation, the standard equation for any ellipse? Well, at least for a horizontal ellipse, it's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. So let's see which one of these informations we have. First of all, do we know h and k? Well, yes, we do. We know what h and k is. This is our h value, the x coordinate of our center. This is our k value, the y coordinate of our center. Do we know a? And as a matter of fact, we do. The a value, the oh so prestigious a value is going to be the distance from my center to my vertex. That's going to be my a value. What about my b value? Well, my b value, remember that my b value is going to be this distance. It's going to be half of the minor axis length. Half of the minor axis length, that's going to be b. Right? That's going to be b. And finally, my c value is going to be the distance from my center. The distance from my center, let's go ahead and erase that for a moment. The distance from my center to my focus is going to be my c value. Okay? And so we have all three of our values in one picture, A, B, and C. Let's see which one of these we can easily get really quick. Well, first of all, I can see clearly my A value is going to be from -5 to 1. So what's my A value? Well, what's 1 minus 5? What's 1 minus -5? Let's go ahead and erase that there. 1 minus -5 is just 6. So my A value is 6. Not too bad, not too bad. I can also see my C value pretty quickly. What's -5 minus 0? Well, that's just going to be 5, right? That's going to be a magnitude of 5. Don't worry about the sign, this is just a size. Okay? And so now I can easily find my B value. How, you might ask? Well, remember, recall the relation. Recall the relation that c squared is a squared minus b squared for an ellipse. So my c squared is 5 squared. 5 squared. My a squared is 6 squared. And now I just have to find my b squared. So, let's go ahead and check this out. What is this going to be? Well, if you go ahead and do the math, this is going to come out to be what? 5 squared is 25. 6 squared is 36. Minus b squared. And just simple algebra, you find that 11 is equal to b squared. Right? So now we have all the pieces of information we need. Now we just need to plug it in, right? What's my h value? What's my h value? It's -5. It's -5. What's my k value? It's 4. It's 4. What's my a value? Well, clearly you can see it's 6. It's 6. What's my b value? Well, b squared is 11, so b is going to be square root of 11. Right? So you can just go ahead and write here square root of 11. And ladies and gentlemen, that's the equation of our parabola, or sorry, ellipse. Okay, and finally let's do our third example. What's our third example? Well, let's go ahead and check it out. Okay, let's check out our last and final example. Our huzzah, our last final huzzah. Let's see if we can do it. I'm sure we can, given our expertise now. So the only thing I can hope for this last one is that it be a vertical ellipse, just so we can get some variety in here. And I'm not going to have my prayer answered, clearly. Okay, so the vertices of my final ellipse are as follows. So the vertices are going to be -10, comma 5, and 2, comma 5. So I have both of my vertices given. Anything else? Seems like I have nothing else given. Oh, and the eccentricity of my ellipse is 1/6. Somehow that's supposed to help me. So the eccentricity and the vertices are apparently all I need to derive the equation of the ellipse. Okay, now, by taking the midpoint of my vertices, I can get the center of the ellipse, right? So check out what coordinate is changing. It's the x coordinate. We can clearly draw a horizontal ellipse, right? So we can draw in our foci, or our vertices rather. Here's the first vertex. Here's the second vertex. Okay, our first vertex is at -10, comma 5. Our second vertex is at 2, comma 5. Okay, once we take their midpoint, we can get the center. And what's the center going to be? The center is going to be what's 2 minus 10, that's -8. Divide that by 2 to get -4, comma 5. So that's going to be the center of my ellipse. I already have the center. Can I get my a and b values? Well, check it out. I already have my a value. This distance from the center to the vertex is going to be 2 minus -4. So that automatically tells me my a value, which is going to be 6, right? Do I know my b value? Well, let's check it out. We also happen to know that my eccentricity is 1/6. But remember, the formula for eccentricity is c over a. It's c over a, right? Hopefully I didn't get that wrong. Keep me checked there, audience. So if E is equal to c over a, and that's equal to 1/6, I know what my a value is. My a value is 6. So what does my c value have to be? Well, just look at this equation. My c value has to be 1. And so now I can easily derive my b value by the relation that c squared is equal to a squared minus b squared. What's my c squared? It's going to be 1 squared. What's my a squared? It's going to be 6 squared. And of course minus b squared. We're trying to find b squared. So if I subtract from both sides, I get that b squared is 35. And now I have all the information I need. And so now I can just go ahead and plug it back in my formula, ladies and gentlemen. And what is this standard form of the ellipse? Well, the standard form of the ellipse is simply going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, if you're persuaded to memorize this formula, remember that memorization is a crime. So let's go ahead and, keeping that in mind, let's go ahead and just plug in. So what's the information I know? Number 1, I know my h value. That's the x coordinate of my center, which is going to be -4. Okay. What's the k value? That's going to be the y coordinate of my center, which is 5. What's my a value? Well, my a value is 6, as you can see clearly here. So I'm going to have 6 squared on the bottom. And finally, what's my b squared? Well, if b squared is 35, clearly b has to be square root of 35. And there you go, ladies and gentlemen. There you go. That right there, this right here, is the equation of my ellipse in all its glory. This right here. All right, folks, that concludes this lecture of vector calculus, and we'll check you out next time.